Hello everyone and welcome to this new Inventor 2019 video tutorial. So we previously, in our previous tutorials, we modeled this piston, this connecting rod, this crankshaft and this gudgeon pin. So in today's video tutorial we will be 3D modeling an engine block so we can assemble everything together. So I will now create a new document. So I'll click on New and I'll go on Standard Mill IPT. So I'm going to start by creating a few parameters. So my parameters will be, I'll click on Add Numeric. I'll call the first one cylinder DIA. The diameter of my cylinder, I'll keep it as 80. Again, as I said, even if this doesn't fully match the diameter of your piston, because it's parametric, we can always adapt it afterwards, once we've started assembling everything, and allow some room for tolerance. So I will now add another numeric parameter. This one I will call it offset and will be 15 mil. The next one will be my pitch, will be 110 mil. The next one will be block length, just realized I was overwriting pitch, so I'll add another numeric. This one will be block length and I will make it 500 mil. Now I'll add another numeric. This one will be block cuts and I'll make it block length times 0.92. And I'll add another one. This one will be crank bearing and will be 52 mil. So I'll click on done. I'm done with my parameters and I'll start a sketch on the XY plane. So I'm going to draw two circles at the origin. The first one is going to be I'll give it a dimension and I'll enter my list parameters and that will be crank bearing. And now I will draw another circle and this one will be 80 mil. Having drawn this, I will create a basic shape. For my engine block, I can now add a few dimensions. So the length of this line is going to be 115. The length of this line, I'm going to click on it, and now instead of the horizontal length, I want the actual length, so I'm going to hover over the line, left click on it again so I can pull the dimension. So that's going to be 200 and with this one I will do the same. This one will be 192.5, and now I'll make sure that these two lines are at right angles, so 90 degrees, and now I'll make sure that these two lines are at 135 degrees. In order to finish it, I will now align the endpoint of this line. I'll add a vertical constraint with the center, so both points are now aligned. And I will now draw another line from the center to here, so we can see that's perpendicular, so that's going to be where the piston goes through. And I'll draw a few more lines, so one line from here to here. So I'll make this line, I'll apply a parallel constraint between this line and this line. I will now right click on this line, make it a construction line. I will do with this line what I did previously. I will use a vertical constraint to align this endpoint to the origin. And now I will use a couple of offsets. So I'll use offset and offset this line by 11 mil. And I'll offset again in the opposite direction by 30 mil. So we have to make sure that these lines fully intersect. So for that purpose, I'm going to apply a coincident constraint between this endpoint and this line. So they're now together. And I'll do the same here. This endpoint and this line. And now I'll do what I previously did. I'll apply a vertical constraint between this endpoint and the center. This endpoint and the center. So we've got half of the sketch. In order to get the other half, I'll draw another line from center to top. Also turn it into a construction line. And that will be my mirror line. So I will highlight everything we see here. Go on my mirror tool. Select my mirror line. Select my line. And click apply. So that's our line now mirrored. And now I will edit this dimension. It looks a bit too big, so I'll make it 119. That seems better, and I'm going to now draw a triangle here. From this line, it's going to move in the -y direction by 68 mil and up till it vertically intersects with this line. I will do the same on the opposite side. I'll draw another line, 68 mil off, and vertical intersection with that. So that's my sketch now complete. I will finish my sketch, and I'm now going to extrude it. So I will select this profile, this profile, this profile, this one, this one, this one, and this one, and I'll extrude it in both directions. And my distance will be go on your list parameters and select your block length and click on OK. I will now apply another extrusion. As you can see, it's asking me for a 2D sketch. That's because when we first extruded this, our sketch became hidden straight away. So I'll right click on it, select, click on my visibility. So after turning on the sketch, we can go on the extrude tool and extrude this cut off. So I'll select both directions, and instead of block length on my list parameters, I will choose block cuts. Make sure that you switch from join to cut, so you should get this. I'll click on OK. I will now go back to my sketch, and I'm going to add another feature for my camshaft. So I'm going to draw a circle, 50 mm diameter. I will now use a vertical constraint, and I will now apply a dimension between both centers. So that will be 130 mm. Finish my sketch, and I will now extrude that feature and that feature all the way through in both directions. The distance will be through all, so you should come up with that. So I'm now going to turn off my sketch. So I'll go back to my model tree, right click on it, turn the visibility off, and I will start another sketch on this face. I'm going to use my project cut edges, and I'm going to plot a point here, for instance. I'm now going to draw a couple of lines. So I'm going to draw a line here going across, and I'm now going to offset it. So the next thing that I will do, I will turn both of my lines into construction lines. I will give my first line a coincident constraint between the midpoint and the center. And now I will give this line an offset. Before I will align it, so I'll use a vertical constraint between the midpoint and this point. So it's now aligned, and I will now offset it from this line. I'm going to type in my parameter, so I'm going to go on list parameters, and that's going to be my offset. So I can now enter a dimension from here to my point, and this is going to be 165. Now I will also apply another distance between the point, this edge, and that will be 85 mm. So that's now done. So I will exit my sketch. I'm going to go on the hold command, select my point, so I will select it will be a simple hole. My termination, I'll say distance and make it 200 mil. My diameter, again, it will be a parameter which we set earlier, so I'll go on list parameters and it will be cylinder diameter. So that should be fine. Maybe I'll make it a little bit longer so the exit is cleaner. I'm going to click on OK. And the following thing that I will do, I will create a rectangular pattern, select my whole feature. Now I'm going to select the direction, which is going to be in this direction. I'm going to switch the direction. I'm going to use 4 units, and my spacing is going to be my list parameter, offset. No, sorry, it's not the offset, it is so my spacing is going to be 110. I'm going to flip the direction and click on OK. So that's one side done. I will now go back to my initial sketch for the hole, and I'm going to plot another point, and this time I'm going to dimension it from this point, so it's going to be offset 55 by 35. So I can now finish my sketch. So I'm now going to use the hole tool again. I'm going to select my hole, my point, sorry. For some reason my sketch is off, so I'll turn it on first. I will now go on hole. Has already been selected. So in this case I'm going to use a tapped hole. I'm going to use an ANSI metric or an isometric profile. The size is going to be 20. So I'm going to use an M20 2.5 pitch, and my depth is going to be 50 mil here and 60 mil there. So that should be enough. I'll click on OK. So I'm now going to apply a rectangular pattern. I'm going to select my hole. I'm going to select my direction, which is going to be along this axis. I'm going to flip it. And I want in total 5 units. And my spacing is going to be same as the pistons, 110 mil. I also want to have them in the opposite corner. So I'm going to select direction tool. It's going to be this direction, and I need to place them by a distance of 70 mil. So in this second menu I'm going to type in 70 and switch the direction. So we should get this with the pattern. So I'm going to accept it. So that's our holes done. So the next thing that we'll be doing, I'm going to use a circular pattern. And my features are going to be hole number 1, rectangular pattern 1, hole number 2, and rectangular pattern 2. And my rotation axis is going to be in the origin, my Y axis. So for my placement, I want 2 units in total, as we can see here. And now you may be wondering, why are you not mirroring it? And it's simply because if we mirror this, the pistons, the 2 cylinders would be aligned, so the con rods will collide. So because all of these piston holes need an offset, by using a rotational pattern, the image would be the opposite on the other side. So that's exactly what we want. So I will now click on OK. So we're getting there. So the next thing that I'm going to do, we need to clear the inside a bit, so our crankshaft can fit in and pistons and con rods can move up and down. So what I will actually do is I'm going to start a 2D sketch on my XY plane. Now I'm going to slice graphics, and I'm going to project cut edges and sketch the following. I will now draw a center line. So shift and turn it into a construction line. Sorry, right click I meant. Now we can add a few more dimensions. So we can say the distance between this line and the center is 168. Now the distance between this line and the origin is going to be 80 mil. Now I want to make sure that this line is 25 mil, sorry 25 instead of 35. And I'm going to use a vertical constraint to constrain this endpoint to the origin. I am going to make sure that I apply a parallel constraint from this line to this line. Now the length of this line is going to be 100 mil. And now we'll add a few fillets. So 10 mil fillet between this line and this line, 10 mil fillet between these two lines, and 10 mil fillet between these two. So I can now mirror all of this across to the other side. And this is going to be my mirror line. Click on apply. I will cancel it because I didn't want to select my projection lines. So what I will do instead, I will use my red selection tool. go on mirror, select my mirror line. So that's now done. I will now draw another line to close my profile up. I will give this line a dimension. I think it just needs a vertical dimension. So 35 is fine. And now we'll finish my sketch. And I'm going to hit extrude, select my profile, both sides, cut, and I will use distance, and I will use list parameters, block cuts, and click on OK. So it looks like still intersecting there, so I'll go back to my sketch. I will edit it, and I'll change its length from 25 to 20 and see what happens. I will try again, and I will make it 10. Finish my sketch. So that looks better now. And the next thing that I will be doing, I will be creating a few ribs. So I'm going to create a plane. So I'm going to click here and use the option offset from plane. So this is going to be my plane. I'm going to pull the arrow in this direction and type in minus 140. And now I can start a sketch in this plane. I will use slice graphics again. I will use my project cut edges tool. I will now use my offset tool, and I'll try to offset all of this geometry back to 0. So I've just projected it. Now I'm going to get rid of these lines that I don't want. And these lines. Because I only want this profile, and now I will close it from end to end. And give it a dimension. So I can now finish my sketch, and I can now extrude my rib in both directions by 15 mil. Click on OK. And now I can use a rectangular pattern, select my rib, select my direction, shift direction, so I want 3 of them in total, and the spacing is going to be the same as the piston, so 110. So that should be enough. I will now click on OK. And right click on my work plane and turn the visibility off. Something that you should make sure is if you go to your original sketch, this was initially 165, change it to 160, so the cornrows can fit in. I'll finish my sketch now. So we've got our ribs, and now we should make an opening so our crankshaft can go through. So I'm going to go back in time. I'm going to move my end of part, and I'm going to edit my sketch, and now I'm going to draw a circle from here and make it 65mm. I'm now going to finish the sketch, and I will extrude. Before I extrude, I need to turn my sketch back on. So I've turned the visibility back on, and I will use extrude, select my object, both directions, cut, and instead of distance I'll select to next, or between, select this face and select this face. So I will now click on OK. I will now move my end of part down. I will click on rectangular pattern, and here under features I will add my extrusion and click on OK. So that's our ribs now done. I can turn off my sketch. I'll change the material. Maybe still polished. So we have a very basic block. This will be the end of this video. Your next task will be to add more features to this engine block. So you could add some channels for the flow. You could add some opening here for push rods to go through, and because at the moment we don't have any access to the camshaft. You could always create some space there for gaskets, or some holes here for bolting the engine block to the crankshaft casing. Some features here for gears or pulleys. Same on the other side. So it's just about making it look prettier, but at least now we have something that you can work on, and that you know that it fits with every other part in your final assembly. So that will be your next task. Crankshaft casing, adding more features to this engine block. Something else you could do as well is you could always add, if you feel like you could have added something previously, you can always go to your model tree, move your end of part up, and go back at any time and add new features. So that's the magic of Inventor, that you can always add new features without undoing anything. You can just go back in time, add the feature, and go forward in time again. So this will be it for this video. So thank you very much for watching, and I'll see you in the next one.